Hello, this is Hui. Welcome to watch my video C++ Programming on Linux. In this short video, we are going to discuss Posix Semaphore. In one of previous video, we discussed the lockable shared memory object, which in order to prevent two processes to update lockable shared memory object, we introduced the inter-process mutex mechanism. Here is one of concept of previous video, lockable shared memory object. So this is the shared memory we allocated for 1024 bytes. And in order to make this shared memory as object, we put this inside a struct. We call the shared memory message struct. And in order to prevent this shared memory being written updated by multiple processes, we introduced another member which called the inter-process mutex. We name it mutex. And during this mechanism, we needed to create a lock object, which is the inter-process mutex lock object, which each time when we try to update our shared memory, we're using the lock.owner method to check if our process is the owner of this object or not. If we are not the owner, we're using the lock method to declare the ownership of this object. In the meantime, if other process is locked this object, this lock action will be waiting until the other process release the object. If we are the owner, so we can update items in our date object, which is our shared memory object. Posix Semaphore is another mechanism or algorithm for allow processes and threads to synchronize their actions. So this is another concept of synchronize processes and threads. So semaphore, it means traffic light. And here is the concept. We have an intersection. We have car A and the car B. It means the process A and the process B. When both processes come to intersection, which is our shared memory, if both processes coming together in the same time, which is the two cars come to intersection at the same time, it will be cause accident. So we introduce the semaphore in each intersection. Each semaphore has a red or green. So this car B, which means the process B, come to intersection, he will watch this semaphore 2. If this semaphore 2 is green, so this car B can go in through intersections. This car A, which is our process A, come to intersection. If this semaphore 1 is red, this car A, which is the process A, will be wait until it became green. So this is the concept or algorithm how semaphore it works. Here on the Linux, we create two programs called the pshm create and pshm open.cpp. Both programs share the header file called pshm. So in order to create a shared memory object, we declare the shared memory, we call the buffer, which is buffer size defined as 1024. We create two members, it's semaphore 1 and semaphore 2. This is a Posix named semaphores. So in order to use struct shm buffer to make this as a lockable shared memory object. Here on the program, pshm create the steps for the create a shared memory. First, we have to create shared memory object. The function is called shm open. So shm open or shm unlink, which uses the create or open or unlink Posix shared memory. So this shm open, which create Posix shared memory object. After we create this shared object, we have to set up the size, which is f truncate. And then we have to map this object into the memories using the mmap. We have discussed mmap in previous videos. and the mmap got address, which is the void pointers. Because we use our shared memory object, which is the SHM buffer struct type, so we have to casting this void address pointer into SHM buffer point. So this is we got our shared memory object. Then we have to initialize our semaphore. We declare the semaphore inside our object, so we have using SM init to initialize our semaphore 1, initialize our semaphore 2. This is the 4 steps to create our shared post semaphore object. So the program we are going to do is post SHM create, which give a name, which is our shared object name, and we assign to the pointer called SSM pass. Then we use the SSM open, and this is the name, and the flag we are going to use is create executable and read write. This is the flag for second parameter, and third parameter is the permission, which is the user for read and user for write. Return back is FD file descriptor. If this is success, and then we use FT truncate, which is our FD we got from SHM open, and the size, which is size of EOF, our shared SHM buffer struct, which we declare in our header files. So now we create our shared object, and with size, then we use an mmap to map this shared memory object into memory. Return back is the address of this memory, and then we have to casting this pointer into our struct SHM buffer type pointer. Then we got SHM pointer, which is the shared memory pointers. Then we initialize our semaphore. We using the SM_init, which is the semaphore 1, and this second is the flag process shared. If this is 0, which is our semaphore working for the same process for multi-threading. If this is 1, it means this semaphore able to share between processes. And 0 means the initial value. Same thing for the SHM semaphore 2 is 1, and the values initial with the 0. Then we try to use a function called show semaphore value. We defined in our header file. It is the show semaphore value. We're using the semaphore get value to get the semaphore 1 value into value 1, and the semaphore get value 2 into the value 2, and we just print off value 1 and value 2. So after that, similar as the previous video, we create a loop. We use user interactive. We have an option for get, wait 1, wait 2, post 1, post 2, read and write. This write action, which is write message to memory. Its read action is read data from the memory. And for the semaphore, a semaphore is an integer whose value is never allowed to fall into 0. This is about the semaphore. So 2 operations can be performed on semaphore. One is called a semaphore post, and the other is SM wait. So in our program, we have 2 semaphores. So wait 1 is wait semaphore 1, wait 2 is wait semaphore 2, and post 1 is post to semaphore 1, and post 2 is post to semaphore 2. When the wait 1 is selected, we use SM_wait to the semaphore 1, and then we display the value after we did SM wait. When the wait 2 is selected, we use SM wait to wait semaphore 2, and then we show the value after SM wait executed. When the post 1 selected, we just use SM post to post to semaphore 1, and we show the value after post. And when post 2 selected, we use SM post to post to semaphore 2 and show the value on the semaphores. And the read is a read buffer to print out. So this is the SHMP buffer is the memory we share with other process. When the get selected, we just show the value of our semaphore, both semaphore. And of course, if write selected, we get the into buffer from the command line or the console to write a message into our buffer, which is local memory, and we make a memory copy to our shared memory buffers. The other program we call the PSHM open. Then the PSHM1, the usage, which is the PSHM1 open, the name. The name is the same as we use PSHM create. So we assign this to the pointer called the SHM pass. And we using the SHM underscore open to open Posix shared memory object. And the path is from command line. And this object we open for read and write. And 0, it means offset from the 0. And returned from the FD, which file descriptor. So after that, we use the MMAP exactly same as we do with create and casting to the SHM buffer pointer to get SHM pointer. In this program, we use one line to create a SHM buffer pointer. In this create program, we use two lines. First, we use the MMAP to get the address, which is the void address, and then we casting our void address to the SHM buffer pointer. So this exactly same as we use in one lines. So exactly same as we are PSHM create program, we use a user interactive. We have a get action, wait 1 action, wait 2 action, post 1 action, post 2 action, read action, and write. You know, if wait 1, we use the SHM wait for the semaphore 1, wait 2, SM wait for the semaphore 2, and post 1, which is SM post for the semaphore 1, and SM post 2, which is for the semaphore 2. And read, we just read memory to print out, to see out, and we are using the get action, which shows the value of our both semaphore, and when we write, we get our message from the console to our local buffer, and we memory copy our local buffer to the shared memory buffers. Now let's save all the program. We compile our program. In order to demo how to work our program, we use two terminals, and we have two processes. One is the PSHM create, another one is the PSHM open. So under the bottom terminal, we run the PSHM create. So we give our object name called myPSHM.dat, and on the top of the terminal, we run the process PSHM open, and have to be the same object name, myPSHM.dat. So at the beginning, you can see our both semaphore 1 and the semaphore 2 and is 0. So start with the bottom create. If we want to write a message into our shared memory, first we post 1, make our semaphore is 1, which semaphore 0, it means this semaphore is red light, and the semaphore 1 is green light. So each time we write, first we have to check if our semaphore is green or not. We use the wait 1. Because our semaphore is green, so wait 1, no stop, just return back. This process watch semaphore 2. So if we are doing the wait 2 here, because our semaphore 2 is 0, it's red, so this action stay hang there, waiting, its semaphore became green. So now we can write something. So we write a message. This is a Hui test message from the PSHM create 1 into our shared memory. So after we finish write, so we need to do the post 2 to make our semaphore 2 become green. So when our semaphore 2 become green, so this wait 2 will be released immediately. So if we read shared memory, so this is a Hui test message from the PSHM create 1. And this is what we write when we write. This is a Hui test message from PSHM create 1. So this is the concept how the Posix Semaphore to synchronize two processes to access same shared memory object. Hello, this is Hui. Thanks to watch my video. Hopefully this is useful, enjoyable. It's going to be great to have your feedback.